Hello and welcome to the relationship section of the National 5 video tutorials. Today we're going to look at identifying trig graphs. So here are the three different types of trig graphs that you could be asked about. The sine graph we know starts at 0 on the x-axis. It moves up to 1 at 90 degrees along the graph. It moves back down to 0 at 180 degrees. It's down at -1 when you hit 270 degrees, and then finally it finishes off at 360 degrees back at 0. The cosine graph is slightly different. It's a similar kind of shape, but we start off at 1 at 0 degrees, down to 0 at 90 degrees, then -1 is at 180 degrees, 0 at 270 degrees, and back up to 1 at 360 degrees. So the sine graph ends at 0 and starts at 0. The cos graph starts at 1 and ends at 1. The tan graph is a little bit different. It starts at 0 and goes up to very, very close to 90, but it never actually touches 90. And then it jumps down to a negative value, and then it rises up to 180 at 0 as well, and then it rises up to 270, never touches 270, and then goes down to just beyond 270 and works its way up to 0 at 360 degrees again. You more than likely won't need to know too much about the tan graph. It's the sine and cosine graph that tend to be asked about in exam experiences, but every once in a while a tan graph creeps in. So it's worth knowing some of the values of a tan graph. Okay, so now we're going to talk about some of the things that can affect these graphs. The first thing we're going to look at is amplitude. And basically what the amplitude does is it stretches out a graph vertically. So instead of going up to 1 and down to -1, this graph of y equals 2 sine x goes up to 2 and down to -2 at its maximum and minimum values. So putting a 2 in front of our sine x value stretches it by a factor of 2. Similarly, if we've got 3 cos x here, it's going to go up to 3 at its maximum value and down to -3 at its minimum value. Okay, so putting a 3 in front of our trig function has the effect of stretching its graph by that factor. The period multiplier is another thing that affects a trig graph. If we put a 3 next to the angle of sine x, what happens is the pattern of sine x repeats itself 3 times within 360 degrees. So that's where the first one starts, and that's where the first one finishes. Here's where the second one starts, and the second one finishes. And then here's where the third one starts, and the third one finishes. Okay, so we've got 1, 2, 3 repeats of the same pattern within 360 degrees, and that's what the period multiplier does. For the second one, we've got a 2 in front of the cos x angle, so we've got 1 cos x from there to there, and then we've got another cos x from there to there. Okay, so again we've got 2 repeats. Here's one slope, here's the second slope. The final thing I want to talk about, as in changing trig graphs, is something called a phase angle. Now the phase angle moves the graph horizontally, left or right, depending on what the angle actually is. If we've got a negative angle next to our sine x, then it is going to move the graph forward or to the right by that many degrees. So in this case, in the sine graph, it should start at 0, 0, but what we've got is we've got our sine graph starting at 0, 30 over here. Instead of going through 0 at 180, it's going through 0 at 210, because that's 30 added on to 180. And instead of finishing off at 360 degrees, it's actually finishing off at 390 degrees because it's moved on 30 degrees. Similarly, if we've got a plus angle on the end of our trig function, that is going to move our graph this way, backwards or to the left. Okay, so instead of starting off at 0, our cos graph is starting off at -45 degrees. Instead of being at its lowest point at 180, it's actually at its lowest point at 135 degrees, because that's 45 taken off 180. And instead of finishing off at 360, it's actually finishing off at 315 degrees, 45 away from 360. So the phase angle, if it is negative, has the property of shifting your trig graph forwards or to the right, whereas if it's positive, has the effect of shifting your trig graph backwards or to the left. Right, so now we're going to look at an exam style question. The question says the graph of y equals a sine bx is shown below. Determine the values of a and b. Okay, so we can just put an a underneath here and a b underneath here. A is in front of the sine x. It is an amplitude. B is in with the angle of sine x, so it is a period multiplier. Okay, so the amplitude of the graph, first of all. How far has this graph stretched vertically? Well, we can see that it goes up to 2 and it goes down to negative 2. So our value for the amplitude is 2. For the phase multiplier, sorry, the period angle, the sine graph repeats once, twice, 3 times, and then 4 times within 360 degrees. There's 1, 2, 3, 4 repeats. So our b value is going to be 4. Okay, and that's how you do this type of question. It's all about reading the graph, all about knowing which position things are in. So amplitudes come first as a multiplier. Period multipliers go next to the angle, and if you've got a phase angle, it's going to be next to the angle with a plus or a minus as well. Here's one more example with a cosine graph. Again, we've been given an amplitude and we've been given a phase angle here, which is a little bit tricky. Now, we'll put down our A, we'll put down our B. The amplitude shouldn't be too difficult. It rises up to 3, it goes down to negative 3, so our amplitude is 3. The phase angle is a little bit more tricky, but if we concentrate here, we know that this cosine graph should start at 0. It's not started at 0. In fact, it's going through 0 at 0. And normally it goes through 0 at 90 degrees on the x-axis. So we know that graph has been moved 90 degrees. B has to be the value 90 degrees. Okay, if you'd like to try some SQA past paper style questions on this topic, then here are your links. Remember, they can all be downloaded for free from the SQA website. And keep studying, and thank you for watching the video.